So for today, we're going to be solving some equations with either radicals or rational exponents. So when you are done with this lesson, you'll know how to solve simple radical equations. Doesn't matter what the index is, we'll be able to handle that. And also we are going to solve equations with rational exponents. In example 1, we have the cube root of x minus 4 is set off to 0. I think you're pretty familiar with what we have to do here. I'm going to guess you already know what I'm about to tell you. In order to get this job done, we are going to need to isolate the radical. Isolate the radical. Isolate the radical. How are we going to do that? We're going to get rid of that negative 4. We're going to get rid of it with a positive 4. And whatever I do to one side, of course, I do to the other. That leaves me with the cube root of x equals 4. Now here's the part I'm wondering if you know what to do next. And I'm going to guess that you do. How do we counter an index of 3? If you think or said by raising the power to 3, you would be correct because the index of 3 counters with a power of 3. Whatever I do to one side, I do to the other. We are done getting this problem solved because we have x by itself. And now we have 4 to the third is 4 times 4 times 4, or 64. And that is our answer for example 1. All right, let's move on to example 2. Where in this particular problem, I don't have a radical, but I do have a rational exponent. And I have to get that by itself. So just like the radical, I have to isolate the variable, isolate the variable, isolate the variable. How am I going to do that? I'm going to get rid of that 2 that's multiplying by dividing. And when I do that, I am left with x to the 3 halves equals 125. Now, I need to get x to the first power. So can you think of what I have to multiply that 3 halves by to get that to a value of 1? Yep, you're right. 2/3. Whatever I do to one side, I do to the other. If you multiply this 3 halves times 2/3, you're going to end up getting a value of 1. And that's exactly what we wanted to do. And I'm just going to go ahead and write what I now know I have, 125 to the 2/3. We're not done yet. We have to simplify this. But before we do, I want to make sure you understood what we needed to do, so I want you to write this down. In order for us to counter the 3 halves, we're going to multiply by the reciprocal. So let's get that in our notes. All right, so we know to multiply by the reciprocal. Now can you figure out a way for us to simplify this 125 to 2/3 without using your calculator? Do you remember a skill that we learned on how to rewrite that 125 with a base of, let's say 5? 5 to the third equals 125, and I still have that 2/3 to multiply by. And when I do that, I'm left with x equals 5 squared, or 25, and that's our answer. In example 3, we have the square root of 4x minus 7 plus 2 equals 5. And we're going to follow the same process we did back in example 1, and that is to isolate the radical, isolate the radical, isolate the radical. That would mean to do what? We gotta subtract 2 from both sides, and we are left with 4x minus 7 equals 3. Now remember that the radical is acting as a grouping bar, so therefore the negative 7 is hanging with the 4x, and they cannot be separated. They are together. So I have isolated the radical at this point. There's nothing else with it. And now I'm going to counter what's understood to be this square with a power of 2. Whatever I do to one side, I do to the other. So this square root counters the square, and I'm left with 4x minus 7 equals 9. Go ahead and use your simple algebra to get the rest of this job done, and x equals 4. That is your answer. Now it's time to refresh your memory about something here. How do you go about doing the following? How can I go about solving this 5 square root 3 all squared? Do you remember how to do this process? It's going to look like this. This means 5 root 3 times 5 root 3, right? The trick here is that I know you're going to go ahead and square that root 3 times root 3 and get a root 9. But are you also going to remember that you have to square the 5 and get 25? Because that's important. We know what the root of 9 is. It's 3. So the answer here is 75. So very important here that you remember to multiply the numbers. I just wanted to refresh your memory on that. So in example 4, first thing we have to learn to do is to isolate the radical. Isolate the radical. But there's 2 radicals. So now what? Well, here's what we're going to do to get that job done. We are going to put a radical on both sides. So make sure you balance that out and put a radical on each side. And we'll be able to isolate a radical on each side. This is where we're very, very tricky. We can be sneaky here. And so I'm going to add that 2 root x to both sides, and that's going to leave me with a square root of 3x plus 2 equals 2 root x. Now, I can go ahead and square both sides. So if I square this side, I'm going to get rid of the radical, and I'm going to square the side with the 2 root x. And so I'm left with 3x plus 2. However, over here, this means 2 root x times 2 root x. And what does that give me? Just like I showed you in the prerequisite, we are going to have to multiply those 2's and get 4. And then, of course, we have the square root of x squared. And so I'll be able to take this out because it counters each other. That was the goal to multiplying or creating this power of 2. And so I have 4x on one side and 3x plus 2 on the other. It's pretty simple from here. I'm going to subtract that 3x from both sides, and I'm already done. X equals 2. Wasn't that cool? Now in example 5, we've got a little bit of a twist coming up here, so make sure that you listen to this entire explanation because we have something special going on here. Now we have to isolate the radical, and it's already isolated, so we're ready to already take our next step. And that would mean for us to go ahead and counter that square root with a power of 2. Whatever I do to one side, I do to the other, and I'm going to act as a group on this side, so I'm going to square the x minus 4. That would require us to use the F word. We are going to FOIL. So that would mean that I get x squared minus 8x plus 16. And then these cancel, the index and the power cancel, leaving us with 2x. So once again, I have to FOIL that x minus 4, and that means that I have to F, O, I, and L. Combining like terms, I get x squared minus 8x plus 16. So with that, now that I have a square and I'm in a quadratic equation, which we learned how to solve previously, I am going to have to get everything over to one side. So get everything over to one side. And we should know that. And once I do that, I go ahead and still incorporating skills that I know from previous lessons. I now have to MAF this. So now I'm going to MAF. And when I do that, I'm going to go ahead and get the following. I went ahead and made a little box, and just to recap quickly, that means I'm going to find factors that add up to 10. Factors of 16 are 2 and 8. And if I make them both negative, then this will work out correctly. So 2 and 8. And so that would mean that I have an x and a negative 8 and an x and a negative 2. So my quantities are x minus 8 and x minus 2. And I'm going to set both of these to 0. Look at all these old skills that we're putting into play here. You got to love it that you learn stuff you're going to continue to use. That is just incredible. And so I have x equals 8 and x equals 2. And so it appears that I have two answers. The only problem here is that I have to check for what we call extraneous solutions. What that means is I have to go back to the original and check these. So get this in your notes that I have to go back to the original, and it must be the original equation, and check both answers. So that's what we're going to do right now. All right, go back to the original equations and check both answers. Okay, so I'm going to go back to this x minus 4, and I have equals the square root of 2x. And I'm going to put parentheses and put in my substitution. So having the parentheses in front of the 4, my first answer was an 8. So I'm going to go ahead and sub in the 8. And I'm going to see if the 8 works. Let's take a look. So does 8 minus 4 equal the square root of 16? 4 equals 4. So yes, I know that 8 is a solution. So far I've got one answer. Let's go ahead and check the other one that I have, which is the 2. So we're going to do parentheses minus 4 equals the square root of 2 parentheses. And let's go ahead and plug this in and see what we get. We've got this 2 here, and when we work this out, 2 minus 4 equals the square root of 4. Careful here, this is a negative 2, and does that equal the square root of 4, which is 2? And the answer is no, it does not. So this is an extraneous solution right here. Extraneous means that although we got to it by solving the equation, it does not turn out to be a true solution, and it must be eliminated. So our only answer is x equals 8. Yes, you are going to have to do this for your equations. When you do get 2 or more answers, you're going to have to check for extraneous solutions. Okay, so now it's time for you to try. Go ahead and take a look at this x minus 3 equals the square root of 4x. You are to solve it. It will be a quadratic equation if you do it correctly. You will get 2 answers. You will have to check to see if any of them are eliminated. Now, hey, sometimes both of the answers do work. So let's go ahead and give this one a try. Press your pause key, work it out, and when you're all finished, come back. I'll reveal the answer for you. All right, so you worked the problem out, and you're hoping you did a nice job with it, and you did if you got an answer of x equals 9. I saved the best for last, and what I mean by the best is I mean the easiest. Wait till you see this piece of cake. So we have an isolated radical on the left, an isolated radical on the right. We can see that we have a fourth index for both of them. So this will make this very easy. Simply go ahead and counter your 4 with a power of 4, do it to both sides, and watch. We knock out both radicals. What are you left with? You're left with a very easy Algebra 1 problem. Just go ahead and knock this out now and get your answer very quickly here, which is going to be x equals 3. Now be aware that when you go ahead and power out both sides, you do have to check for extraneous solutions. So we are going to have to go ahead and do a check here, but it won't take but a second. So I've got the original equation of 6 parentheses minus 5 equals 4 parentheses plus 10. Always put your subs in parentheses. So let's go ahead and see what we have here. We have 18 minus 5 and the fourth root of that. Does that balance out with the 3 plus 10, which is 13? And the answer to that is yes, indeed. The fourth root of 13 equals the fourth root of 13. And we are done. All right, some things to keep in mind about this lesson is that we want to isolate the radical or the rational exponent before we go ahead and counter that index or the power, whichever situation we're in. And also check for extraneous solutions and make sure you go back to the original equation when you do that. If you're not sure when to check for extraneous solutions, it would be my suggestion that you always check for them.